So what happens when you realize that gravity is um, just a suggestion? Today we are looking at how questioning the actual physics of a toilet saved over $100,000.
Which is just such a wild hook, right?
Right, it is. But welcome to your custom deep dive. And really, a big thank you for sending over this research on industrial logic and vehicle architecture. Our mission today is to uncover the first principles advantage. So how breaking problems down to just, fundamental physical truths gives you an ultimate strategic edge.
Yeah, and to get that edge, you basically have to stop reasoning by analogy. We see this all the time, right? Like when legacy automakers try to build electric vehicles.
Right, they take a frame meant for a gas engine and just like shoehorn a battery pack in there.
Exactly. They are just repeating what they know. But first principles thinking, it strips away all those industry habits. You are just rebuilding a solution governed entirely by physics and logic. Nothing else.
It is kind of like trying to upgrade a horse by giving it better horseshoes instead of just inventing the car.
Yeah, precisely. You are trapped by the mechanical limits of the past.
But wait, looking at their shift toward vertical integration, I really have to ask, doesn't doing everything in-house, like mining lithium, writing software, making your own chips, doesn't that create a massive bottleneck for a company?
Well, people usually assume vertical integration is just this financial play, to capture profit margins. But from a first principles perspective, it is actually about the velocity advantage.
Velocity advantage.
Right, because relying on external vendors for this huge, complex web of parts places a hard physical limit on your speed. By controlling the supply chain, you aren't waiting on, like, an external vendor's roadmap. You can redesign a component and literally have it on the assembly line in a single one-week cycle.
Wow, 1 week.
Yeah.
So you completely eliminate the supplier bottleneck. But what happens when the physical building itself becomes a bottleneck? Because I know that happened at the Nevada Gigafactory back in 2015.
Oh, the plumbing issue. Yes, they had this brutal deadline to hit temporary occupancy for 400 employees.
Right, by Q3 or something.
Yeah.
And traditional gravity-based plumbing meant digging these massive 30-foot trenches across a huge concrete floor, all just to maintain the proper drainage slope for gravity.
Because traditional plumbing is, at its core, a design constraint forced by gravity. So they just asked, well, what does physics actually allow? And they brought in a negative pressure vacuum-based system by Acorn-back.
Instead of gravity pulling the waste down, this closed piping network uses suction to pull it up.
Up into the overhead ceiling space, right?
Exactly. Which means no massive floor cuts. They could literally drop bathrooms or workstations anywhere, just rearrange them on the fly.
That is incredible. And that temporary vacuum center gave them flushing toilets months ahead of schedule. It saved over $100,000 just in chemical toilet servicing and actually reduced potable water use by 68%.
Yeah, they solve for density and time, not tradition. And what is really cool is they apply that exact same mechanical logic to the car itself. Think about gigacasting. Oh, right. Instead of a traditional assembly line where robots perform, I don't know, hundreds of individual welds to join stamped metal,
Right. They just inject molten aluminum into one massive mold.
saving factory floor space and time. And they take it even further with cell-to-chassis architecture, right? Where they stop treating the battery pack like dead cargo bolted into a frame.
Yes, they make the battery a load-bearing structure for the vehicle itself. It is exactly how modern airplane wings are built. The wing doesn't hold a fuel tank. The wing is the fuel tank.
Okay, wait, hold on. If the entire chassis is one giant cast piece and the battery is integrated right into the structure, what happens in a minor fender bender?
Ah, yeah, that is the catch.
Because you can't just unbolt a crumpled bumper and slap a new one on anymore, can
You can't. And you've just hit on what we call the repairability paradox. These highly efficient monoblock structures are incredibly fast and cheap to manufacture, but they are massively complex to fix.
So an accident that used to just require swapping a modular part could now mean replacing major structural sections.
Exactly. The manufacturer saves an absolute fortune during the production phase, but that economic risk is essentially just shifted down the line. It goes straight to the post-sale insurance phase.
Wow. So the efficiency is undeniable, but it completely changes the life cycle economics of the product. That is fascinating. Which brings us to a key insight you can use in your own life.
Yeah, stop accepting the rules of the game established by the past.
Exactly. When you hit a wall, ask what the fundamental laws of physics actually allow. If gravity plumbing stops your schedule, just look to the ceiling.
And here's a thought to take with you. If you applied first principles to perfectly optimize your own daily life for extreme efficiency, What essential human inefficiencies, like traditional craftsmanship or the simple ability to repair what is broken, might you accidentally engineer out of existence?
That is a brilliant point to end on. Thank you again for bringing this incredible material to the table for this deep dive. Keep questioning the rules, and we will catch you next time.